Okay, so this is what a molecule of glycogen looks like. As you can see, these are the individual glucose monomers there, and they form together. They form these branching structures, and they form glycogen. As you can kind of look, there's this weird looking thing in the middle. That is actually not glucose. It's a protein called glycogenin. So glycogenin is in the center of glucose, and it helps hold the glucose together. It gives the glycogen together. It helps the glycogen have something to hold on to. And so we have two types of residues in here, and it just has to do with how they're bonded. So we have our alpha 1,4, which is our typical residue. You'll see just like in line there, but every once in a while you see a branch, and in that case we have an alpha 1,6 because the bond is between the 1 and the 6 carbons rather than the 1 and the 4 carbons. And so those two structures, every 8 to 10 monomers, we get a branch monomers. Cool. And so we're actually talking about how we build this now. So glycogenesis has 4 steps to it, 4 main steps. So we're going to look into those. So in glycogen metabolism, the first step here, this is our glucose molecule here. And as you can see with our glucose molecule here, that we are taking ATP, we're adding a phosphate group onto here, and we are creating glucose 6-phosphate. And this is catalyzed by an enzyme called hexokinase. You might remember that one from glycolysis. So that's the first step. In the second step, we have our glucose 6-phosphate, and we wanted to convert it to glucose 1-phosphate. So we're just moving the phosphate from here to here. So from the 6th carbon, the 6th to the 1 carbon here. And the enzyme that catalyzes this is called phosphoglucomutase. Long word for that. So that just takes the phosphate and puts it on the 1 carbon. So now that this is actually incorrect, I drew that wrong. So it's glucose 1-phosphate here. So glucose 1-phosphate here. And we want to make UDP glucose at this point. And so how that works, we have our catalyzing enzyme here, UDP glucose phosphorylase. And what that does is it takes uridine triphosphate, and it cleaves a phosphate group off of it, and we get uridine diphosphate, which is that's the energy source that in the next step is used to add it on to a growing glycogen molecule. So that's the third step here. Now in our fourth, we have our UDP glucose. At this point, we have UDP added on to glucose, and we want to put it on our growing glycogen molecule here. And so we're going to use an enzyme called glycogen synthase. And what that's going to do is it's going to take the UDP, it's going to come off of our glucose molecule. That's going to provide the energy to bind our glucose on to the non-reducing end, of our growing glycogen molecule. And so then we add glucose onto glycogen, and this is stable at this point. This is something that our body can store. This happens primarily in the liver and the skeletal muscle specifically. And yeah, it's how our body stores glucose, and we can use it when we do not have a ready supply of glucose coming in. We can then undergo glycogenolysis. That's another one of those fun words, and break it down. So we will undergo glycogenolysis. And that's what we'll talk about in one of our next videos, is then how we access this glycogen molecule and break it down to get to the glucose, so we can run cellular respiration.